Welcome back to the PCB Graphics YouTube channel. For the past 6 years, we've been working with the old Heathkit AA-100 tube stereo amplifiers. They're marvelous machines if given a chance. We have literally helped 100 people around the world get their amplifiers working again. I'm starting a new series today, and I'm going to take an amplifier that doesn't work, and I'm going to make it work. We'll do a repair on it. A couple of years ago, I had a customer reach out to me, and he says, Mike, I cannot get this thing to work. He looked at it, he went over it with a fine-tooth comb. He had 3 different amplifier technicians look at it. They couldn't get it working either. And so he was at wit's end and didn't know what to do, and I offered to help him out, but he says, you know what, I've had it, I want to wash my hands of this thing, I'm done with it. And so he offered it to me at a really good price. And so he sent the amplifier to me, and it's been sitting in a box for the past 2 years. Well, today is a great day to do it, and so we're going to crack it open and see what's inside. I'm always up for a good repair challenge, and this thing's been sitting in a box for 2 years, and I never actually unpacked it to see what's inside, so I'm really opening this up for the first time. I was told that this was incredibly well packed, and that seems to be the case. There's a lot of boxes, bubble wrap. So this box here says tubes. Let's pull that out. Nice big chunk of bubble wrap. Ah, here we go. That looks like part of the construction manual, and there's a note there from an amplifier technician from the past. We'll look at that later. Let's see, there's the AA-100 manual on disc. Okay, well here's the box. This is what appears to be an AA-100. These things weigh a few pounds, so I've got to be careful I don't drop it. And that sure feels like an AA-100. It's about 32 pounds, I think. Well, this box looks like it had a little damage to it. But there's definitely an AA-100 in here. There we have it, Heathkit AA-100. It actually looks pretty good. It has all of its knobs, and the knobs haven't turned severely yellow like my amplifier. And this looks like one of the later models because it has the louvers. I have one of the oldest ones that they ever made, and it doesn't have louvers, it actually has slots in it. But let's take a look here. Just overall condition. It's got some scuffs and some scratches. Well, the front panel looks good. This here looks like it may have sustained a little bit of damage somehow. And it's a little bit wobbly, so there's something going on underneath. Let's pull this out and have a look inside. I can see that somebody's been in there before. It looks like a bunch of capacitors have been replaced. It looks like original resistors, new power supply caps, new power cord. Looks fairly clean. I don't see any rat pee or anything really nasty. Although the power amplifier board looks like it's pretty badly warped. Can't tell for sure. Let's flip this up and see what's going on here. It does look like the case has sustained some sheet metal damage. It's just kind of bent out of shape. And there's nothing there that we can't fix. That's kind of gouged out. Looks like somebody may have done some work there at the power switch. It has some cosmetic issues, but nothing really terrible. Okay, this is the box of tubes, and I'm told that the whole complement is in here. So let's have a look. Some colorful newspapers. Oh good, we've got shields. Let's see, we have an EF86, the elusive 7199, another elusive 7199, another EF86, 12AX7, another one, another one, another one, a GZ34. 7591 output tube. Another one. Another one. And another one. Without going through the schematic, it's hard to tell for sure if anything's missing, but it does look fairly complete. What's the first thing you do when you get a tube amp in? Well, I want to check the tubes and make sure that they're really working properly. So let's bust out the tube tester. Okay, we have the mighty Heathkit tube tester. I have no idea how old this thing is, but it works. And it works well. All right, let's check the 7591 first. So the way these things work is you roll the dial around here and you're looking for 7591. I think we're in the 4s right now. Now we're in the 14s. So we're looking for 75. So Heathkit had a neat system where you could roll the dial and find out all the parameters for the tube tester. And you'd go find the tube type, and then it would tell you how to set the filament, all the selectors, and the knobs and everything, so that you could test your tubes. So I'll go ahead and get this set up real quick. This is kind of interesting. So the previous owner of this thing had written out some of the common tubes that he did a lot of testing on. Okay, we've set the filament, and we've set all of the inputs and outputs of the tube, and we need the bias to be set at 10. So we'll turn that down to 10. Whoops, wrong way. Down to 10. Shunt doesn't matter. Multiplier is X10. And then press S5, this button here. And we're looking for a mutual conductance minimum of 500. All right, the machine is ready. So let's plug in a 7591 output tube and turn it on. Okay. That lit up brightly for a second and then went dim. That's a good sign. That means that the filaments are working fine. Okay, one thing we have to check before we do any testing is to check the line voltage. And right there you can see where it says line test. It's running a little low, so I'm going to go ahead and bump this up until it reads right on the money. Okay, that's perfect. All right, let's check the tubes to see if there are any shorts. We're looking for no indication on the meter. Okay, no shorts. Now I'm going to test for mutual conductance by pressing the GM button. And down here in the notes, it says we have a minimum of 500. And I'm looking here on the micro-mho scale, and we have 5, 6, 7, we have just a little bit less than 800. So that's good, it's working. Sometimes tubes can get gassy if there's a leak around the pins and air gets in, or other conditions can cause them to go gassy over time. So let's set this up. We'll follow the directions here and set that to X2. We'll turn this all the way up to 100. We push this button here, and we want to turn this down until it indicates 100 on the micro-mho scale. Okay, there's 250. We'll just turn right down there. Okay, keep your eye on the meter there, and I'm going to press this tube here, looking for gas. If it goes up, it could indicate the presence of gas. Well, it did move. It moved by 1 mark on the meter. The manual says if the pointer movement is not more than 2 scale divisions, then gas content is negligible. So I'm going to call that one a pass. Okay, we're going to engage the shunt. And we'll turn that up all the way. Now we press the GM button and we bring this down, and we basically are unloading it until we get 1000 on the micro-mho scale. Take a look at the meter. See where it says 1,000. Okay, now I'm going to press the life test button. So what this does is it cuts down the amount of filament voltage, and we're looking to see what happens. So predictably, we're going to get a little bit less emissions, but we want to make sure that it stays above mid-scale, which it does. It's still dropping just a little bit, but nothing to be too concerned about. It's just the tube cooling down. So I'm going to call that a pass. Okay guys, Mr. Hickok tells us that that tube is good. So we have 3 more of those to do, and I'll do them real quick and we'll tell you what the results are. The second output tube passes all tests as well. Tube number 3 also passes the test. Okay, all 4 of the output tubes passed the test. But one thing I did notice is that one of the tubes was weaker than the others, and the performance levels weren't exactly even. And that's why the power amplifier board that we're going to put into this amplifier, having individually adjustable bias controls, is really going to help in that regard. So I'll go ahead and take this thing out and we'll let it cool off. But I don't see anything here that's a showstopper with those tubes, so I'm going to go ahead and use them. So let's see what kind of treasures are buried inside this tube tester. Look at that. A mullered tube box. It actually has a tube in it. Back here, I've got an RC8 box, Radio Corporation of America from Harrison, New Jersey, the most trusted name in electronics. And it too has a tube in it. There's a couple of other interesting things down here, old artifacts and things that just got dropped in. Amperex. It's hard to get my big hands down in there. RCA. How about that? There's a little treasure trove down inside there. Okay, next up I'm going to work on the 12AX7s. I have 1, 2, 3, 4, possibly 5. No, that's all. I have 4 of those. So I'll go ahead and test those. So let's go ahead and get this thing set up properly. That is a 12.6 volt filament. Okay, let's do the pin mapping here. So we're at 4, 5, 7, 2, and 6183. Oh, some of those are easier than others. Let's see, bias 14, multiplier at X4. And we're looking for a minimum mutual conductance of 200. That's a dual triode, so it has special instructions. Use adapter SA-41050 or CA-41050-135. Okay, that meant nothing to me. We're going to put it right there. That must be the adapter they're talking about. First, we'll go through the leakage test. Make sure there's no shorts. That looks good. I'm pressing this button, which switches sections, and now we're looking at the other side of the tube. We're looking for any kind of shorts. Okay, that looks good. Time to test the transconductance. It's calling for a minimum of 200, and I have well over that, so that passes. We'll do a quick gas test. I do not see any gas whatsoever. That's good. Okay. We'll go back to X4. Set that back to 14. Okay, I'm pressing down S8, which is section 2. Look for transconductance. We're looking for over 200. We have that. That's good. Now we'll go back to X2. I'm pressing S8. We're looking for 100 micromhos. I think I have to press like 3 buttons at the same time here. So we'll go S8, S6. We'll set for 100 micromhos. There we go. Now press S7. These buttons are stiff. That really gives the arm a workout. Okay, that passes. So the 12AX7 in the socket is good. Now we'll go ahead and check the other three and see how they go. Well, good news, all of the 12AX7s pass. So let's move on to the next type, EF86. I have two of them. The EF86 tube is a very sensitive preamplifier tube, and you can see it has a shield, and that shield keeps out the noise. It's interesting to note that this tube here is a Svetlana tube made in Russia. Well, the EF86 tube doesn't show up in the chart here, and back in the old days you had the American tubes, and then you had the European tubes, which had different numbers but were functionally and electrically equivalent. But we didn't tend to cross them over too often, but occasionally we'd get some foreign gear in, and so they came up with the supplementary data for European tube types. Let's see if we can find the EF86 in here. Okay, it looks like we're getting close. There's EB, EC, EF. There we go. EF86. Okay, so they're just basically going to tell us how to set this up. All right, so in the EF86, first of all, we have 6.3 volts on the filament. We have 5490. 6138. Bias is set to 11. Multiplier for X4. And we're looking for a mutual conductance of 300 micromhos. And then everything else is the same. Okay, the EF86 apparently is a single section tube, so we'll go ahead and treat it as such. We'll turn the thing on and warm it up. Okay, let's check for shorts and emissions problems. All right, that looks good. All right, let's check mutual conductance. We're looking for a minimum of 300 there. And I've got 250, 300. Yeah, I think that's good. I could live with that. Now let's go check for gas. There's that sticky meter again. Okay, gas pass, which is not the same as passing gas, fortunately. And now the life test. Okay, there's 1,000 micromhos. All right, hit it. You can see the meter coming down a little bit, but not much. That's pretty good. So that tube is good and solid. I'll go ahead and do the other one. All right, the EF86 tubes are both looking good. So let's take that out. Time to test the 7199. These are the phase splitters. And what they do is they take the audio, which is going to your power amp tubes, and it basically flips one phase upside down from the other phase. These tubes are really, really hard to find now. They're getting more rare every day. If you have them, please be careful with them. 7199, looks like we're almost there. The 7199 is both a pentode and triode, so it has to be tested twice. Once as a pentode and once as a triode. So we'll start with the pentode section. That is 6.3 volts, 4570. Oops. Two, 360. And we're looking for a mutual conductance of 375 minimum. So we'll set our bias at 7. Multiplier of X10. Let's light it up and get the thing going. All right, short circuit test first. Meter shows 0. That is looking real good. Okay. Now let's check the mutual conductance, which must be 375 or greater. Oh yeah, it's well over 500, so that's good. Okay, let's do a gas check. Okay, we'll set the calibration point, and we are good on that regard. So let's reset everything over here. Now let's do a life test on it. All right, that looks really good. While the tube is still hot, I'm going to go ahead and power this off real quick. We're going to go to section number 2, also 6.3 volts, 4590 this time. And 1080. What this does is it programs the pins and hooks different things to the different pins on the tube. Power back up. The tube is still hot, so we'll let it sit for a second. Warm back up. I've got a sticky button here. I think this GM button's got a little bit of a problem. Let's make sure there's no shorts. Okay, short test pass. Let's check the mutual conductance. Wow. Okay, that was pretty hot. Not sure what happened there. Oh, okay, we forgot to reset a couple of things. That needs to be on X2. I missed a couple of things. Okay, bias of 29. I guess I should read the chart all the way. Multiplier of X2. And we should be seeing at least 650. And we're seeing quite a bit more than 650. This is really, really good. Very strong. Very strong. Okay, now let's check for gas. Well, we already did that. We know it's not gassy, so we don't have to do that. Let's go ahead and life test it then. All right, we'll set our calibration point right there. And now we'll hit the life test button. It's going down a little bit, but not much. Okay, I would say that's a good tube. Well, we had a bit of a scare here a second ago. After a few seconds, we realized that the filaments weren't coming on, and we thought, uh-oh, we have a bad tube, bad filament. That's not good. So we checked this, still nothing. And then I started looking at these switches here, and it turns out that I transcribed a couple of numbers. So it should have been 4570. I had actually dialed in 4750, which maps the filament voltage to the wrong pins. Obviously that's not going to work. So that's all fixed. And now we'll just let that warm up for a moment. Both of the 7199 tubes are in great shape. Let's go ahead and turn that off. We'll disconnect. Yeah, that's hot. Okay. The last thing we have to look at is the GZ34 5AR4. Those two numbers are equivalent. Pin compatible and electrically equivalent. So let's go ahead and take this out. Somebody's actually put a label on there that says GZ34. These are still easy to come by because they're used in guitar amps. So let's see what socket that wants to go into. Probably this one, huh? 5AR4, there it is. Okay, filament set for 5 volts, right there. Okay, we want 8200. And 6400. Okay, shunt is 68. Multiplier set to shunt where it still is. And we'll press the S3 button because it's a rectifier. We're looking for a minimum mutual conductance of 650. And it's a dual diode. So let's read the directions and see what it says for dual diodes. The testing of dual diodes is performed as follows. Okay, so we press the dual diode button S1, 2, or 3 as called for, and the gas test is not applicable. Okay, well, good enough. So let's check for shorts. Wait a second. Okay, that's the main rectifier tube. Did you see that? It lit up brightly and then got dim. So there was a major amount of inrush current to light the filaments on that thing. But that's the main rectifier tube. It supplies all of the high voltage for the entire amplifier. Now it's interesting that the bias supply was done with a solid state diode instead of a tube. Okay, let's check for shorts. We've got the sticky button again. There we go. Check for shorts. Okay, no shorts. Now we'll press the rectifier button and see what happens. We're looking for a minimum of 650, and we have well over 650 there. And let's check number 2. That's good as well. Well, it looks to me like we're done here. It's a good tube. I just pulled this tube out of the tester here. It's a 3A3C by Sylvania, made in USA, and it says on here, warning, set voltages may produce harmful X-rays unless tube is shielded. That's kind of frightening. So thanks to the Heathkit tube tester, we know that all the tubes for the AA-100 are in good working order, so we don't have to worry about those for now. That concludes today's episode as we begin the process of repairing a Heathkit AA-100 stereo amplifier. We'll see you in the next episode when we take the cover off and start probing around and see what's going on.